everyone. My name is Hannah Facey, and I'm a master's student at the University of Guelph in the Department of Animal Biosciences. And today I'm going to be presenting my research on the replacement of soybean meal with black soldier fly larvae meal in broiler feeding programs. So poultry products are one of the largest and fastest growing animal agriculture industries in the world, and is continuously growing each year due to increased wealth and population growth. However, increasing production of poultry to keep up with demand requires increased supply of chicken feed, which is the most expensive aspect to poultry production, sometimes reaching as high as 60 to 70% of the total cost of production on broiler farms. The ingredients driving these prices are the most essential, providing energy and protein, the most common source being soybean meal. However, soybean meal is becoming increasingly unsustainable to produce. It is produced as a monocrop and therefore leads to soil degradation, fertilizer and pesticide pollution, and is produced primarily in South America and the US, where it has high irrigation demands. Additionally, the price of soybean meal has risen drastically in 2020 and into 2021 as weather patterns continue to be unpredictable and future droughts are anticipated to limit supply. The price of soybean meal peaked in January 2021 at $714 a ton, increasing by 33% from May of the previous year. And even though prices have come down since then, they're still currently sitting at 18% higher than this time last year. Therefore, it's becoming increasingly important to find alternative feed ingredients for our growing poultry industry. Black soldier flies are a very promising alternative for a multitude of reasons. Black soldier fly meal is similar in nutritional composition to traditional sources, such as soybean meal, containing approximately 40 to 44% crude protein and sufficient amounts of all of the essential vitamins and minerals, making it a suitable ingredient according to many different strain-specific production guidelines, such as avian. They're also able to be produced pretty cost-effectively as they have a high stocking density. 1 meter squared of space can produce 180 kilos of adult black soldier flies within 42 days. And this is even higher for the larvae. What is really cool about black soldier flies is that they can be reared on biomass and plant waste and can therefore reduce waste pollution by sourcing their feed as byproducts or waste from grocery stores, restaurants, or even the beer and wine industry. And they don't require much else, much more in terms of inputs, as they get much of their water requirement from the food they consume and use their body reserves to sustain themselves as adult flies after they pupate. Black soldier flies are currently not competitive economically, as they're currently priced at about $6,000 a ton. However, they continue to become more mainstream through educational and commercial channels, opening up opportunities to become more cost-effective in their production and processing. They're also available in many parts of the world and could be produced much more cheaply in tropical and subtropical regions of the world where poultry meat production has the highest potential for growth, such as Asia Pacific or Africa. Black soldier flies also have the opportunity as a value-added product due to a substance in their exoskeleton called chitin. Chitin is an indigestible fiber that has a similar chemical structure to cellulose. It is thought that chitin in small amounts acts as a prebiotic in the digestive system and has antimicrobial properties and could therefore promote both gut health and immunity, which could lead to reduced need for antibiotics in the poultry industry. On the other hand, however, chitin in high amounts is thought to cause digestibility issues in broilers, which could hinder growth performance. Research to date has seen various levels of growth depression occurring, typically when black soldier fly meal is included above a 10% level in the diet, according to a 2019 meta-analysis by Mula and Datilia. However, the results vary significantly. Some research has seen positive performance with as high as 100% inclusion, such as the study here done by Wallace in 2017, whereas other research has seen poor performance with as low as 10 to 15% inclusion, such as the Debut paper written in 2018. Therefore, it's important that we now study in depth where the growth depression is occurring and then further examine what is going on metabolically and physiologically at this point to try to find solutions to the impaired performance seen in so many performance trials. So the objective of my research is to examine the influence of partial to complete replacement of soybean meal with black soldier fly larvae meal in broiler feeding programs. And my hypothesis is that broilers will experience a depression in growth when fed diets containing high levels of black soldier fly meal, which would be above a 10% level. So I conducted my study at the Arkell Research Facility in Guelph, Ontario, and used 4 identical rooms within one of their barns, one of their broiler barns. There was 12 pens in each room, which gave me 48 pens in total. And we put 24 birds in each floor pen. So we had about 1,158 chicks in total at the beginning of the trial. The chicks were male raw 7-weight broilers and were allocated to each pen by hatch weight. The pens were randomly assigned one of 6 diets, and the diets were all isonitrogenous with increasing levels of black soldier fly meal that replaced the soybean meal content. So diet A was the control diet, containing 0% black soldier fly meal and no growth promoters or antibiotics. And then diets B, C, D, and E were the basic control diet plus increasing levels of black soldier fly meal. So it was 12.5%, 25%, 50%, and 100% respectively. And then diet F was the positive control diet, which was identical to diet A, but with a growth promoter BMD and a coccidiostat Montalban. Likewise, the control diets used soy oil for energy fortification, and the black soldier fly meal diets used black soldier fly larvae oil. Each diet was formulated with for a starter, grower, and finisher phase to meet the nutrient specifications of the strain. And this trial went on for 49 days, so 7 weeks, and we collected performance data, including body weights and feed intake at day 10, 24, and 49, being the end of each phase. We also collected mortality throughout the trial, and were able to calculate body weight gain and corrected FCR from this data. As an extension of this research, we also sampled birds on day 24 and 49 with hopes to explore the metabolic and physiological aspects of this research, but today I'll only be discussing the performance data. So this is the body weight data for placement, starter, grower, and the finisher phases. Here you can see that all the chicks started at similar weights. However, by the end of the starter phase, you can see that diet E is already starting to have a negative impact on body weights, and eventually diet D as well. What's interesting throughout the starter and grower phases, however, is that diet B and C, which were the diets with lower levels of black soldier fly meal, are actually statistically similar to diet F, which was the growth promoting diet. So they actually outperformed the basic control, which was diet A. Therefore, it suggests that lower levels of black soldier fly meal could actually have some sort of growth promoting effect, similar to antibiotics and such. However, by the end of the finisher phase, this effect evens out, and diets B and C remain at the control level, so closer to diet A, before the rest follow a decreasing linear trend. It's not clear yet why we saw that early growth promoting effect. However, a smaller presence of chitin could be positively influencing gut health, but just becomes too much in diets D and E, and therefore begins to negatively affect the birds. This is the data for body weight gain, and this actually follows the same trends as body weight. You can see the starter, grower, finisher, and then the overall data. And you can see that the overall shows a decreasing linear trend as the level of black soldier fly meal increases. And here's the data for feed intake. There's a little bit more variation in the trends here, but you can see clearly that feed decreased for diet E and then eventually for diet D as well, whereas diet F had a consistently high feed intake. This data corresponds with the body weight results and is likely a major factor in the reduced growth performance. However, that leaves us with the question of, well, why aren't the birds eating the diets with the higher levels of black soldier fly meal? And one theory is that black soldier fly meal is a dark color. It's actually similar to coffee grounds. And the more black soldier fly meal that's added to the diets, the darker they'll become. So as chickens are highly visual animals, it's thought that the variation in color is causing some visual aversion, making the birds not want to eat the darker feed. Lastly, here's the mortality corrected feed conversion ratio results. You can see that as time progressed, the FCR on diets E and D got significantly worse than the FCR on diets F and A. Diets B and C improved slightly over the basic control, suggesting again that there could be some positive impacts on gut health from those lower levels of black soldier fly meal. And this is the mortality data for the whole trial. Diets A, B, C, D, and F were all pretty normal, but you can see that diet E had a pretty high mortality rate, which was partially due to the increased need for euthanasia. The main causes of euthanasia in diet E were lameness, leg problems, or for being a runt, so for not growing fast enough, compared to the main cause of mortality in the other treatments, which was just labeled as found dead. You can see that in the pictures, I've included the birds on diet E were in fact much smaller and more variable in size compared to diet F, and they had very patchy feathers. And this suggests that the high levels of black soldier fly meal, particularly the complete replacement diet, is having some sort of metabolic and physiological effect on the birds, and that further research is required to try to find some more answers as for why the chickens responded this way to the higher levels of black soldier fly meal. So although black soldier fly meal is still not economically viable, it is becoming more mainstream as a product and as a livestock feed ingredient. As for nutrition, I'm interested to find out more about how black soldier fly meal is affecting the digestive tract of these broilers. If chitin is having some positive effects on gut health and immunity when fed in lower amounts, then this could contribute towards making the black soldier fly more economically viable as a value-added feed ingredient. And it's my hope that this research can contribute towards making the black soldier fly a viable ingredient in poultry diets and can contribute towards reducing the environmental footprint of the feed industry. So thanks for listening. These are my funding agencies, and then I have some references listed as well, and I'll be happy to take any questions.
Great. Thanks very much, Hannah. Great presentation, and we've got some questions coming through. Are there palatability issues related to black soldier flies?
Yeah, so if you think about chickens that are free ranging or like the ancestral chicken diet, they do eat insects. If they're out, they'll just like poke around and eat insects. And also a lot of companies that produce black soldier fly meal also produce whole grubs. And there's actually been chickens actually seem to really like the whole grubs when they're fed that way. So no, I don't think there's any palatability issues, sorry. It's just, yeah, something else to do with feed intake that's making them not want to consume as much.
Okay. We're starting to get a bunch of questions. So did you do any analyses on the diet? So did the formulation correspond with the analysis of the treatments?
Yeah, so they were all formulated to be isonitrogenous. So they all had the same levels of nutrients in each of them. So yeah.
Okay, but I think the question is, did you analyze the composition? So did you measure crude protein or amino acids in the diet? Yep, we did all that. Yeah, I don't have all the data right now. I just have what was presented, but yeah, we definitely did do that analysis. Okay, and then a related question, and I think you might have answered this already, but did you do any work on the amino acid digestibility in the soldier fly larva?
Yeah, we measured the amino acid profile, not necessarily the digestibility of each, but yeah.
Okay. And does the chitin content differ between the larvae and the adult fly?
Sorry, does the protein content?
The chitin.
The chitin content. Yeah, that's a good question. I know chitin is pretty high in black soldier flies. It varies between different insect species. Yeah, and I think at the time of harvest, so when they're large larvae, it's about 6 to 7%. But yeah, that is a good question. I would assume yes, because the rest of the nutrients do vary as well. Like protein and fat content will decrease as they age. So yeah, I don't know exactly, but.
Okay, great. And then I just have one final question. I was having some technical difficulties and I saw the slide, but you were talking about what can be used to feed the black soldier fly, and some things were allowed and some things weren't. But because of the variability in the source of the feed for the larvae, are there risks of potential microbial contamination with foodborne pathogens?
Yeah, so in Canada right now, the only thing that's really allowed because of the regulations to be fed to black soldier flies is like food waste. Mm-hmm. So yeah, I mean, that is approved in Canada, but so as the larvae, when they're processed, when they're like harvested, they're actually sanitized, and the sanitization process will actually empty all of their guts. So I don't think there is much risk of contamination, but yeah.
Okay. All right. Well, thank you very much. It was a lovely presentation, and good job answering the questions.